All right, good morning, guys. We are going to be talking about inequalities today, less than, greater than, but first I have a couple warm-up problems. The first one is off worksheet 17, side B, and you may want to grab your little yellow sheet, okay? Yours is yellow, right? But number one on that sheet about graphing these is to do what always? Yeah, factor everything. What can I do to the top here? Okay, if I take out an x, I have x squared plus 3x plus 2, which will further factor x plus 2x plus 1. Does that seem okay? All right, the denominator down here, how will that factor? Someone could hit the light switch closest to the phone if they wanted. This is off worksheet 17B. Okay. Now, before we do anything, you should state the domain restriction. Okay, it doesn't say that here, but on the quiz it would. So what are the things the domain cannot equal? Okay. The second thing it says on here, it says factor, do the domain, and then look for a hole. Is there a hole? Okay. This x plus 2 factor is top and bottom. So there is a hole when x equals what? -2. Okay. So we have to find the ordered pair of the hole. And to do that, a whole bunch of you, when you took the quiz last week, which will be re-quizzed, you didn't divide that out. If you don't divide that out, you're going to get 0 over 0 if you put it in correctly, because -2 is going to make that 0 and that 0, okay? But if you divide that out, now when we put the -2 back in, we have -2 here, -2 plus 1, and -2 plus 4 down here. So we'd have a -2 times a -1 over a +2. What's all that become? 1. So at -2, 1, there's a hole. All right. The next thing on the sheet is vertical asymptotes. Anything that makes the denominator only 0. Why does it say only? Kelsey, you with us? Okay, what makes the denominator only 0 can't make the numerator 0, okay? Can't be the whole. There can't be a vertical asymptote if there's a hole. So left, we just have x equals -4, and it needs to be an equation because it is a line. It is not part of the graph, it is a boundary. All right, the next thing on the card is the zeros and the y-intercept. Zeros, which are the x-intercepts. That would make the top 0, which will make the top 0. Okay, so if we put in a -1, we'd get a 0. And this x out front means if we put in 0, we'd get out a 0. So I'm thinking we just found the y-intercept as well. Because the y-intercept is when you put in a 0, what do you get out? Well, if I go back to the original, guys, if I put a 0 in here, this will be 0, this will be 0, this will be 0, this will be 0, this will be 0. I just get 0 over 8, right? Which is 0. Okay? I don't know if I can erase that, so let me just do that. So there isn't a separate y-intercept. 0, 0 is both the x and y-intercept, but it does also cross x at -1. Interesting. Okay. All that's left is the end behavior, number 7 on your card. It is top heavy or bottom heavy here? Yikes. Do you know what we have to do when it's top heavy? We have to divide, okay? We have to divide ignoring the remainder. Okay, do you have that in front of you guys? So if I open a new sheet here, because to divide this, what goes in here? X cubed plus And out here is x squared plus 6x plus 8. Did I remember that one right? Okay. It seems horrible. Can't do synthetic. Okay. But it's really not going to be that bad, because what is the one thing we're going to multiply by to get this? So x times all this will be x cubed plus 6x squared plus 8x. Yep, we have to subtract all of those. So we get negative 3x squared and negative 6x. So what can I do to make this into this? Okay. So I get negative 3x squared minus 18x minus 24. Do I care about anything beyond that? It's going to be remainder, right? Everybody okay? So our end behavior equation is y equals x minus 3. It is an oblique asymptote, meaning it's at a slant. Negative 3 is down here, okay? And it's going up 1 and over 1. So we have this, roughly. Now, there needs to be something on either side of the vertical asymptote, right? I wish I had this typed in already, so that we didn't have to spend a lot of time on this, but I don't. So it's x cubed, someone help me, plus 3 plus 2x, all divided by x squared plus 6x plus 8. Did I remember it right? All right, so if I do a standard window, well, I can see the part that looks like it fits to our graph, right? But if there's an x-intercept over here, or I'm sorry, a vertical asymptote over here at -4, there has to be something to the left of that. What do you want to try? It can't. There has to be another piece of the graph on the other side. That's the reason there's a vertical asymptote, is because it's splitting the graph. So there has to be something over here to the left. So if I change this to like -20, I don't think it's going to show me anything. But do you think it's up or down? You think it's up high? Otherwise, what we can do now is a zoom 0 just so it shows up. Okay, I wouldn't leave that window necessarily, but it definitely is down. All right. So I'm just going to trace so I get an ordered pair. Oh yeah, it's down so far it's not going to fit on our graph paper, is it? Okay. So, whoops, that's got nothing to do with anything. So I'm just going to trace through here. There is a hole. It is touching these points, and then it's going this way. And there's another piece down here. Is that good enough? Yes. Right. It's instead this oblique asymptote. And I do want to show you what happens. If I zoom out here a couple times, zoom, 3, enter. Okay. Zoom, 3, enter. What do you notice? Does this, if I now go back in graph in blue, the line y equals, was it x minus 3, guys? Was there, that's all you really see, right? Because all along this function, it really is just y equals x minus 3, except right in near the vertical asymptote. So the whole time this function was approaching y equals x minus 3, except when we zoomed in close and looked near the x axis here. Okay. All right. So that was a review of some of those concepts. The other thing I want to review that's on Friday's quiz is finding all the zeros. This Friday? 2.2 and 2.3. This is from actually this is from 2.4, which is on next Tuesday's quiz, but we're practicing. Okay. Do you remember how to find all the factors, all the possible zeros? You don't have this one. If you want to write it down somewhere, you can. Remember how to find all the possible rational zeros? Okay, all the factors of 66. What would go into 66? 1, 66, 2 and 33, 3 and 22, 6 and 11. That seems like it. Do you think that's it? I can't think of anything else. Okay. And the denominator is the factors of the leading coefficient. So 1 and 3. Lovely. Okay. So that list would be 1, 2, 3, 6, 11, 22, 33, 66, and then put them over 3. Well, 1/3. What else? 2/3. 3/3, 6/3 that are good. 11/3. 22/3. Okay, because all the rest, like 33 over 3 is 11, which we already have. Is everybody good with why we didn't write some of them? Okay, that's a lot. Do you remember how to do the next part of this? To find the factored form is our goal. The directions say graph and divide. Okay, so I typed it in and I graphed, and can you see what that one says? It had a 0 at 2, and it had a 0 at -1. Now, there's 4 places it crosses, but when I found the other one, I got this. What does that mean? This is basically 0, right? But is that a rational 0? No, it's something crazy. So what were the 2 that we needed, guys? Oh, you guys are good. Okay, -1, and it doesn't matter what order we do it in. Synthetic division, 3, -3, -39, 33, and 66. Okay, who's got a calculator? Bring this down. -1 times 3 is -3. -6 times -1 is 6. -33 times -1 is +33. 66 times -1 would be -66, 0. What was the other one? +2. Okay, bring down 3 would be 6, 0, 0, -33, -66, 0. Okay, how do you write the factored form? This says, yes, this is a 0, this is an x, this is an x squared. Okay, so that says 3x squared minus 33. Is that factored? What can we do? So we have a 3. X squared minus 11. Does that factor further? No. Okay, are we done? It was a degree 4 polynomial. Where are the other 2? X plus 1 and x minus 2. Okay, because we had a 0 here and a 0 here. If we were to FOIL this all back together, it's got to go back to what we started with up here, okay? Now, what are the 4 zeros? Because this is what I'm worried about on the quiz. The zeros, we found 2 rational ones at -1 and 2, but what are the other 2? 3 is not one. Okay, if we set this equal to x squared minus 11 equals 0, we get x squared equals 11. Yes, plus or minus square root of 11. Do you think that might be the crazy decimal that I showed a minute ago? Yeah. Okay. Any questions? All right. Yes. No, it was just a blank. Thanks. I was just like, on the quiz, there'll be a blank where you have to write the zeros. It's not over anything. Yep, there's just 4 of them. And then there'll be a blank that says y equals, and you're expected to have the factored form here. Okay? Good question. All right. That brings us to today's lesson on inequalities. This is section 2.6. And there are, I think, 4 questions on the quiz from 2.6. Maybe even only 3. I can't remember for sure. But we split this lesson in 2 because we're going to talk about the polynomial inequalities today, and then we're going to talk about the rational or fractional inequalities tomorrow. All right, so this is pretty easy if you look at it graphically. So if we have this crazy polynomial graph over here, and it asks me where is the function less than 0, if this was -4, -2, +2, and +5, you would say it's less than 0 or below the x-axis in between -4 and 2, and in between 2 and 5 over here. And then this piece also goes down over here, so that's from 5 on. Everybody seem okay? So if it asks where it's less than 0, you would say those places. If it asks where it was maybe greater than or equal to 0, okay, you would say to the left of -4, which would be written like this. And because of the or equal to, you'd use a square bracket. Then from -2 to +2, it's also above or greater than. And because it said or equal to, you use a square bracket. And then because of the or equal to, it's actually at 5, it hits 0. So they just said 5 to 5 here. There's not one like that on the quiz. All right, so let's look at what you have on your worksheet. This says x squared minus 3x minus 15 is greater than 3. It's much easier if you just always compare it to 0. So if we subtract 3 from both sides, we'll have x squared minus 3x, and minus 15 minus 3 more would be minus 18. And it was a greater than. Everybody good? Got to know these symbols, guys. Okay, this is greater. And the one that's like an L smushed over, that one's less. And I know the alligator thing, but the alligator thing doesn't work when I'm asking between 2 variables, because you can't tell which is eating which, okay? You have to know, is it greater than or less than? Now, this does factor. So we get x minus 6 and x plus 3. Is that right? Yes? So we have zeros at 6 and at -3. So we already know that it's going to have a 0 at -3 and a 0 at +6. Then we can graph it. Some of you wouldn't even need to graph it. You guys know this is a parabola that opens up, right? If it's crossing twice, you know the shape it's going to be, that it's going to have a dip here down below, however low it goes. Then our question was, where is it greater than 0? And you need to answer in interval notation. Greater than 0 means above 0, right? So you need to tell me out here and out here. Okay? So how do you tell me that direction from -3? DeAndre, what's happening here, guys? How do you say to the left of -3? Until -3. Do we need a square bracket or a parenthesis? It wasn't an or equal to, right? So we just need a parenthesis. Then it is again above 0 from 6 and off to the right. So you would say together with 6 to infinity. Any questions before we talk about another example? Seems pretty easy. All right. This is just a weird little example. It says x squared plus 2x plus 2. If you do, it doesn't factor. You'd have to do quadratic. You'd get imaginary answers. I would have started with the graph. the graph looks like this, does it ever become less than 0? No. So you would say no solution, or, okay. If it asked where it was greater than 0, what would you say? If it said x squared plus 2x plus 2 is greater than 0. Any ideas? How would we say all of this is greater than 0? What are the x values? What? All real numbers, right? We graphed it. The whole graph is above 0. So we want to say no matter what x value you put in, you're going to get something above 0. So if below 0 was no solution, above 0 is all real numbers, which is negative infinity to infinity. All right. Do you have this example too? No? Okay. So can you graph the, well, I did it for you, so you don't have to if you don't want to, but I typed this graph in, okay? And I got this. What I really need to know, I want to know where it's what. What does this say right here, guys? Less than or equal to 0. So that means below the x-axis, yes? Everybody with me? So less than or equal to, so here was the graph, okay? And it had a 0 at 3, and it's definitely below over here. So at 3, it was doing something like this. And then I had to be a little careful over here because I couldn't tell, was it crossing or what? -1, it had a 0, okay? But it also had a 0, could have zoomed in a little better to see it, but it also had a 0 at, what is this value? -2/3, yes. So here's 0, or the y-axis in here somewhere. Over here at -2/3 it crossed, and then at -1. Okay, once I have found all the factors, then what I want to know is where is it less than or equal to 0? Anybody? Yes, from the left until I hit what? -1. So from negative infinity until -1, inclusive or not inclusive? Because it's or equal to here, we need a bracket at -1. Okay? Then where is it below again? Because it's less than. Okay? If you're not sure what you need to do on a graph like this when it's hard to tell what's going on in here, you could have zoomed in for sure. But you can test a value in between those zeros. And that's what I did here. Okay, -1 and -0.6, right? So I just put in a -0.8, and it turned out to be a positive value, so I knew it went above there. All right, let's hope you have these now. Okay, you have this one? Okay, does this factor? How does this factor? If I factor this 2 and 1, the only way to get -3 is for these both to be negative. Does that make this work at the back? Okay, let's graph this. It might be none, but it might also just be ugly numbers. Okay, what is it, guys? All right, and I'm just going to look in a standard window. Well, it looks like it does have real solutions, right? But are they nice? No, because we know it doesn't factor, so they're not nice. Okay, we'll come back to the graph in a minute, but hopefully I didn't put one like this on the quiz, but what are we going to have to do? No, we graphed it. Doesn't factor. When a quadratic doesn't factor, what's your next choice? Yeah, we need to do quadratic formula. All right, what is the opposite of b? Plus or minus the square root of b squared minus 4 times a times c, which is, c is -2, right? Over 2 times a, which is just 2. So I have 3 plus or minus. What happens back here? Yeah, because this is plus 8, right? So we have square root of 17 over 2. All right, so if I go back to the graph, if I were to go trace, what did you just tell me? 3 plus the square root of 17. I don't think this is going to work because I needed extra parentheses, didn't I? No, I need the whole thing divided by 2. Okay, comes out exactly 0. What's this one over here then? 3 minus the square root of 17 divided by 2. Okay, why can't I just write down the decimal? That's not exact. Okay, so on our graph, the parabola is doing this from 3 minus the square root of 17 over 2 to 3 plus the square root of 17 over 2. So where is it less than 0? Yes, in between here is what we want to say. Do we need square brackets or parentheses? It doesn't have an or equal to, okay? If it had these, then we would need square brackets, but it doesn't. So we're just going to have 3 minus square root of 17 over 2, comma 3 plus square root of 17 over 2, and I don't think you have to do one like that on the quiz. That was pretty gross. Okay, I think they get better. I hope they get better. Number 2, does this one factor? X plus 1, x plus 1. What does that mean? If you have x plus 1 quantity squared, what does that mean about this graph? What does it do at -1? It bounces because it's a squared, right? Okay. If I were to write this in vertex form, what's the vertex of this parabola? Yeah, -1, 0. Should it be opening up or down? Positive x squared. So that means it's opening up. It looks like this. You can graph it if you want. So where is it greater than 0? Almost. Almost. Yes, because it doesn't say or equal to 0, right? So it's greater than 0 to the left of -1 and to the right of -1, but it's not greater than 0 at -1. It is 0. So how do we write to the left and right of -1? Everybody got number 2? Both of those are a little bit harder than what's on the quiz, I think. There's one like this on the quiz. What's the first thing you want to do? No. No. It has to be in respect to 0. So we're going to have x cubed plus 6x squared plus 5x minus 12 is greater than 0. Then I typed it in. and I graphed it and I got this. What does it look like? +1, -3, and -4. Okay, I don't even know if that's right. Let's type it in and see. Someone read it to me. X cubed. Okay, did I mess it up or is that right? All right, so if I do trace -1, oh, that's not it, -1. +1. Yeah, let me try that again. It is a 0. What do you know? What about over here? We think -3 is 1. Yay. And -4 is 1. Okay, so we found all the zeros by graphing it. So we know we have -4, -3. What was the other one, guys? +1? Okay. Now, we need to decide where it's greater than 0. The graph was doing this, wasn't it? Between -4 and -3. And why didn't I put square brackets? Should I have? Because it's not an or equal to. And then where else is it above 0? Okay. Now, what I've shown you down here is using the table, you could figure out, double check that it's above in all those places. Okay. Number 4, what's the first thing you want to do? Yes, you want it to be compared to 0. Does that factor? To get a 3x squared, only factors of 3 are 3 and 1. Only factors of 2 are 2 and 1. If I do that, I'm going to get 6, right? That's not going to work. If I switch these, okay, now I have 3x and 2x. How do I get a +1 out of that? Plus the 3x and a minus a 2x. That working now? So, did we find the exact solutions? Here's the graph down here, which I could have predicted because it's a parabola opening up, right? So this over here is -1, and this is +2/3. So where is it, what does it ask? Less than 0. Okay. What if it had said less than or equal to? Then we would have just had this. Okay. Any questions so far? Seem pretty easy? You have to do 1 through 5. Okay? On worksheet 15A. It's a worksheet, no bookwork. 1 through 5, that's it. All right. Could you take out worksheet 13 real fast? I just want to do one of these today. I'm trying to go above and beyond what I will probably ask on a quiz a little bit to get you to think about all the properties of rational graphs. I'm going to do this number 2 right here. Number 2 on worksheet 13A. It does look like a lot of stuff going on. But this is what I want you to concentrate on for a minute here. It's crossing at -3, +2, okay? It has this is supposed to be a dotted line, by the way. It has a vertical asymptote where? X equals -1. And over here it has a vertical asymptote at x equals 4, and it has a horizontal asymptote at y equals 20. All right. So what do you know because of those things? We're supposed to write the equation. What's what? Oh, this is the limit. We can talk more about those in a few minutes. Well, I mean, we could do it. This says the limit as x approaches negative infinity. What does this mean, guys? X arrow negative infinity. To the left. Yep. So as I go off to the left, what does it look like this is getting closer and closer to? Yes. As I go off to the right, what is our graph getting closer and closer to? 20. All right, this is new notation. This says -1 from the left. It does? We're doing number 2. 13A, number 2. Okay, so negative, that little negative up there, after it means from the left. So if I were getting closer and closer to -1 coming from the left, what would this graph be doing? So we'd have negative infinity. The next one says x is approaching -1 from the other side, the right side. So if I were to follow the graph and get closer and closer to -1 coming from the right, I would be doing what? Going up. You don't have to be able to do this for a quiz. This is calculus. I'm just trying to help you see. But do you understand that on either side of this asymptote, it's going opposite directions? Okay. What about it at this asymptote over here at 4? From the left, it's going down, and from the right, it's going up. All right. When it's doing opposite things, it means there's no squared. Okay, we'll talk more about that on another day. I just want to get one of these done today. Okay, but guys, tell me, if it has x equals -1 as a vertical asymptote, what do you know about the function? Look on your yellow sheet. When it has a vertical asymptote, it has what? It is going to be equal weight because y equals 20 was our horizontal asymptote, okay? But what about vertical asymptote? I don't know if there's a whole. Vertical asymptote. Is it like number 4? If it's a vertical asymptote, then x minus b is a factor of the denominator. So what do I know is in my denominator for this question? An x plus 1. What else is in my denominator? An x minus 4. Okay. What do I know is in the numerator? A 20? Is that what you said? Yes. There is a 20 because it's got to have a leading coefficient of 20 so that the equal weight, right? But what else is on the top? What says set the numerator equal to 0? What says on here set the numerator equal to 0? Guys, not complicated questions, right on the card. Setting the numerator equal to 0 will find you what? Oh, zeros are x. Okay. So where is there an x-intercept? So that what does that mean about the top? Well, x plus 3, right? Because it's got to be, if you put in -3, you get out 0. What else? There's x minus 2. Okay. Now is it equal weight? Do we have an x squared on the top and an x squared on the bottom, right? Okay. I don't know if we need anything else, but let's try typing it in. All right, I'm going to put a giant parenthesis around the top. What did we have on top? A 20 and an x, what is it? Plus 3 and an x minus 1. Is that right or not? Minus 2 on the top. Okay. Close all that parenthesis, divided by giant parenthesis around the bottom, around what's in the bottom? X plus 1. Is that right? And x minus 4. Okay, what's the window that's actually on the graph we have? Guys, tell me what's on the graph. Negative 8 to 10 and negative what? Can you tell?
75.
Okay, I'm just going to leave this. It says roughly negative 75 to positive 60. Is that what it is? Up and down?
What's the other?
Okay, this is what we got. Is that looking like ours? The only thing I want to try is I'm going to put in 0. If I put in 0, I get out 30. Does it look at all like ours might be crossing at 30? Yeah, it's above 25, right? We are geniuses. Okay, we wrote an equation for a graph. We're going to practice this again tomorrow. All right, so your homework tonight is to do 1 through 5. That's it. On worksheet 15A. How many of you can honestly say that you're doing more homework than you usually do and you're kind of close to being anybody? Nobody? How many of you have done any of the homework for this homework check? How's that? Everybody's hand should be up because we did part of worksheet 10 together that day, right? Okay, guys, you're really disappointing me. There's only 5 questions and they're on a worksheet tonight. Please do them. Because the other 5 get harder and I want to know that you know how to do the easy 5.